So last video, we took a random sample of 5 students and found the mean of their exam scores. And this isn't the exact same sampling distribution that we had last video, but we redid the data and we got this looking graph. So it goes from all the way below 60 to above 90. That's pretty crazy, but it's based off of this data here. So we got some 20s, 30s, 40s, 50s. So if we get a bunch of those and some low ones, then we're going to get below 60. If we just pick a bunch above 90, we're going to just pick 5, well, not pick, but randomly select 5 above 90, then we can possibly get a mean above 90. So that's if our sample size was 5. So then this topic, we're going to repeat that, and we're supposed to do it with a size of 10, a sample size of 10 students instead of just 5. So I went ahead and did that, and let's take a look at what happened. Was now our low is 68 compared to our low is below 60, and our high up here is 82 compared to our high here above 90. So what effect has increasing the sample size had on the sampling distribution? Well, it's kind of shrunk the range down. And so what that means, so our range is smaller. And so that means that we have decreased the variability. So when we take larger samples, then what we're doing is we're going to get closer and closer to the mean, which should be about 75 or 76 right there. So we're kind of compressing all of our values closer to the mean, decreasing that standard deviation as well. So we can write that down, that increasing sample size will decrease the variability of the sampling distribution. And to quickly wrap this up, we're going to take a look at this box on the next page. We got a few ideas here. First, we want to talk about parameter versus statistics. So a parameter, remember that P describes a population. There's that P again. Whereas a statistic describes a sample. So that S and the S and the P and the P. Sampling distribution. You may notice the topic right above it. What is a sampling distribution? It is the values of the statistic, whatever we're talking about. In this case, it was the mean of the midterm scores for, in this case, so this is the value of that statistic for all possible samples from a population. And then finally, we're going to count the dots. How many dots are there? We did that in the first section. Let's go back to that real quick when we were looking to see how many were below this 68 to see how likely it is of that occurring. And so you'll see that again when you're working down here. You're going to count the dots. And if we see something that's less than 5%, happens less than 5% of the time, that's going to be statistically significant, convincing evidence. So that's going to be, for the most part, that's going to be our baseline, is it greater than or less than 5%. If it's less than 5%, then, something's out of the ordinary. So that kind of shouldn't happen a lot of time and won't happen. So either we, repeat again and see if it happens again, or we just say, hey, this happened. It's pretty low. It's statistically significant that maybe what we should be seeing isn't actually what we're seeing. So class will go over application 6.1, probably do some more work as well. See ya.